Hi everyone, welcome back to the next sliding window protocol discussion. In the last video, I discussed about the 1-bit sliding window protocol, and we also discussed how it works with just maintaining a sender's window size of 1 and a receiver's window size of 1. There, for it to work efficiently, we have to consider that the transmission time from the sender and receiver and for the acknowledgement to be received back is negligible. But that's not the case in all the networks. It might be different. Now, let me show you an example where this does not work out and where stop and wait protocol could be rendered inefficient. So imagine that this is my sender and this is my receiver. Okay. So what happens is at time 0, the sender starts its transmission. So he has started sending a packet at time 0. The time taken for the sender to complete this transmission of packet, that means to send the last bit of this packet, is 20 milliseconds. Okay. So from time t is equal to 0 till t is equal to 20, the sender is busy. So he has been transmitting it from 0 to 20, and at 20 milliseconds, the packet has been transmitted and now is in transit. So according to the stop and wait protocol, what does the sender do? Yet from 20 milliseconds onwards, it has to stay quiet. That means it cannot transmit anymore and has to wait for the acknowledgement to come back. Assume that it takes 250 seconds from the sender to receiver. Okay, so as I said, at time 20 milliseconds, the frame transmission completes at the center, and this frame is reached at the receiver at 270 milliseconds. So at 270, this entire frame is received at the receiver. So the receiver receives this entire frame and it has to do the error checking process and everything. Now, once it has completed the error checking process, it is happy that everything is okay. It will send an acknowledgement back. For this acknowledgement to be back to the sender, it takes another 250 milliseconds. So from 270 plus 250, a total of 520 milliseconds is the acknowledgement received, and only then the sender could be active again and start sending the next frame. Now, if you take this scenario, there is no problem because the sender has sent a frame and waited for the acknowledgement to come back. It has started a timer, and according to the timer, it will wait for the acknowledgement. And if the acknowledgement is not received, fine, the sender will start retransmission. Here, everything goes well and the receiver has received the frame. But the problem is, check out the duration of the time where the sender remained active. So starting from t is equal to 0 till t is equal to 520, the total time that the sender is active is only 20 milliseconds. So 20 milliseconds out of 520 seconds is just around 4%. So if you have a long transmit time and high bandwidth and a very short frame length, that does not do good for networks. It doesn't work well because the sender is sitting quiet and the bandwidth is being wasted. So there has to be a solution to overcome this problem. The simple solution for this problem is to use a concept called as pipelining. What do you mean by this concept? As the name itself suggests, pipelining is a kind of technique where we can make the sender send multiple frames and then wait for an acknowledgement. Rather than just sending one frame and waiting for an acknowledgement to come back, here the sender can wait for multiple frames, then wait for an acknowledgement. Of course, you can ask me, how many frames does the sender can send? 1, 2, 3, 10, 20, 30. That is all dependent on the buffer size. That is the amount of memory that is available at the sender to hold the frames in memory. Coming to the solution which I proposed, which we call as pipelining. Pipelining is a process of sending multiple data packets serially without waiting for the previous acknowledgement. So the sender here in this case can send multiple frames rather than just simply sitting idle till 520 milliseconds. If you could send multiple frames and slowly the acknowledgements keep coming back, I can have better bandwidth utilization. The main advantage of pipelining is to use bandwidth better. rather than making the sender sit idle and just wait for the acknowledgement to come back, I can make the sender send multiple frames. Okay. So in this particular techniques or usage of this technique, the protocol or the first sliding window protocol that we come across is called as GObacknarq protocol. You are all aware that ARQ stands for automatic repeat request. That means the absence of an acknowledgement automatically tells the sender to retransmit the frame. The receiver, if it did not receive any frame, or if it has received the frame with errors, it will simply sit idle. It won't send any acknowledgement. The sender, on the other hand, will check for the timer, and if the timer runs out, it will now check whether it has received an acknowledgement or not. Then it will infer whether the packet has not been delivered or whether the packet has been delivered with errors, or even the acknowledgement might have been lost. But for any other reason or for any of these reasons, doesn't matter. The sender will simply retransmit the frame. Okay, that is what we call as automatic repeat request mechanisms. We study the first protocol which uses pipelining called as go back and sliding window protocol, which is in this particular protocol, the n here, what is this? This n determines the size of the sender's window. I explained to you in the earlier video where the size of the sender's video is nothing but it is the number of buffers at the sender. That means how many frames the sender can keep in the memory. That is what we call a sender's window. The number of frames the sender can send at a given point of time. How many outstanding frames it can have is nothing but which is equal to the size of the sender's window. Okay. So the value of n defines the number of frames that can be sent while the sender is waiting for the acknowledgement. Now, let me show you a small example. Let the sender's window size is 7. The sender can have at most 7 outstanding frames at any point of time. Here you have to remember that the receiver's window size is equal to 1. That means the receiver can only accept the frames that have been received in order. Out of order frames are simply neglected. They are simply dropped off. They are not accepted. Okay. So this is the initial setup. So this is my sender and this is my receiver. Okay. So this is my sender's window. So as I told you, let me assume that the sender's window size is equal to 7. That means I have 7 buffers at the sender, but the receiver's window size is only 1. That means only 1 frame it will accept and it will only accept in order only. So because the sender's window size is here, the sender has issued the first 3 frames, F0, F1 and F2. So these 3 frames have been transmitted. Let us see. Okay. So these 3 frames will be received at the receiver one after the another. As the size is 7, the sender is permitted or is allowed to transmit all these frames starting from 0 to 6 and then wait for the acknowledgement. Okay. So once the F0 is received at the receiver, it will verify whether this is received with any errors or not. And if it is satisfied with it, it will forward this to the network layer and then send an acknowledgement back. Once again, the acknowledgement 1 tells you that the receiver is expecting the next frame sequence 1 or the next frame with the sequence number as 1. So once F1 is received, it will send an acknowledgement back as ACK2 and then F2 is received. So in this way, slowly after one after the another, the receiver will verify whether the frame it is receiving has been received in the exact order or not. Because the receiver's window size is 1, it can only accept 1 frame. So it cannot accept the frames which have not come in order. For example, if F2 goes first, then F1, the receiver will not accept it. It will only accept F1. Similarly, once these acknowledgements are coming back to the sender will slowly slide this window. So what happens? See, once the acknowledgement 1 comes back, the sender will know that the frame number 0 has been successfully transmitted. So this edge of the window is now moved to the side. And similarly, this edge of the window is also moved. So now my window is from 1 to 7. The acknowledgement 2 has come back. So this window has been slided to the further direction. So 1, 0 and 1. Similarly, next comes ACK 3. SEK3 means all these 3 frames have been delivered successfully at the receiver. Now the window contains this. You might ask me, sir, if you don't have 7 frames, what happens? Fine. If you don't have 7 frames and if there is no more data to send by the receiver, slowly this window size will shrink. And at one point of time, when there are no frames, the window will be empty. That's all. If you don't have frames to send, why would you keep a window? You don't. Now, let us assume that in this case, F3 has not been received by the receiver. So it is expecting F3 and unfortunately F3 has not been received. And because it takes a little bit of time for the sender to recognize this, it has sent F4 and F5. But both these 2 frames, F4 and F5, will be discarded by the receiver simply because it is expecting frame 3 only. Even though frame 4 and frame 5 might have come in excellent condition without any errors, it will not accept. It has to accept only frame 3. So what will the receiver do? It will do nothing here. What will the sender do? Because for each and every frame it transmits, it starts a timer. At one point of time, the timer for frame 3, which has been not acknowledged, will expire, and the sender will now know that, okay, fine, there is some problem with this. And starting from 3, so the name of the protocol tells you go back n. So you go back to 3 from where you didn't receive your acknowledgement or where your leading edge is, and you have to retransmit all the frames that have been transmitted in this manner. So the current outstanding frames that I am having is F3, F4, and F5. So because I did not receive an acknowledgement frame 3 and my timer has expired, so what I will be doing is I will be retransmitting all these 3 frames again. The name itself tells you go back n. So you have to go back to the frame which is yet to be acknowledged first and for which the timer has been expired. From that frame onwards, how many number of frames are still outstanding? All of them have to be retransmitted again. There is no other way around it. The problem is, if there is a high error rate, if there are too many errors on the link, this particular method will obviously lead to more and more number of retransmissions. But the good thing is, the number of buffers that is required at the receiver is only 1, because the receiver's window size is 1, which allows the receiver to only accept the frames that have received in order. Any out of order frames will be discarded by the receiver. This is a simple protocol, nothing there. So slowly, once the frames have been acknowledged, the window will be slided towards your right hand side. And if there are no more outstanding frames, both the edges will be coming closer. And if there are no frames at all to deliver and there are no outstanding frames, both the edges will converge in one position, which tells you that the window is empty. Okay, so the frames at the sender side are numbered sequentially. As I told you, for each and every frame that is being transmitted, which makes use of a sliding window protocol, has to have a sequence number attached to it. Unless until there is a sequence number attached to it, it becomes very difficult for the receiver to identify any duplications or lost packets. In GObackn, the sender can buffer n frames, whereas the size of the receiver window is 1, which means the receiver can buffer only 1 frame at a time. What do you mean by this buffer n frames? N frames means here I am telling you that the sender can have at a point of time up to 7 outstanding frames. What do you mean by 7 outstanding frames? The sender can send all these 3, 4, 5, 6, 7, 0, 1 and then wait for an acknowledgement. It has got 7 buffers. It can send 7 frames and then wait for the acknowledgement. Once the acknowledgement comes in, these buffers will now start holding the new frames with new sequence numbers. So the window slowly slides forward. Okay. So the receiver discards all subsequent frames following an error one and sends no acknowledgement for those discarded, as I just told you. So here, F3 has not been received by the receiver. It is still expecting F3 and it then got F4 and F5. It cannot accept this F4 and F5 because it has got only one buffer, and in that buffer, it only has to accept F3. So what it will do? It will simply sit idle. It won't do anything. It is the job of the sender to verify when the timer for this particular F3 has expired and then proceed further. What do you mean by proceed further? It has to simply retransmit all the frames starting from the first frame for which the timer expired. This is called as go back n ARQ protocol. As I told you, go back n means n is nothing but to the point or to the sequence number for which the acknowledgement has not been received, and all the outstanding frames starting from that serial number onwards or starting from that sequence number has to be retransmitted again. Let me show you another small thing with this particular protocol. In the go back n protocol, the size of the sender's window must be less than 2 power m, where is m is the number of bits. I found this example from the Faruzan's textbook. The receiver's window is always 1. There is no discussion about that. Okay. Now, let me show you. So, in this particular example, the sender has selected the sequence number to contain as 2 bits. The sequence numbers contain 2 bits, which makes it m is equal to 2. So, my theory tells you that you have to select the size of the sender's window, anything less than 2 power m, which tells me it can be anything between 1 till 3, because 2 power m is nothing but 2 square, which is 4, and it cannot be equal to 4. It has to be less than 4. So in this example, we are taking 3. Now, this is the starting point and this is the ending point. What did the sender do? Because it can have 3 frames transmit at any point of time. It has sent 0, 1, 2. Okay, these are the first 3 frames that have been transmitted. This has been transmitted, this has been transmitted, this has been transmitted. What happens here is these 3 packets have been received well at the receiver. That means there are no transmission errors. So obviously what will happen once packet 0 is received, the receiver will slide to 1 and send an acknowledgement back. And once packet 1 is received, the receiver will slide to 2 and send an acknowledgement. Once the packet 2 is received, it will send an ACK3 and it will slide to the further direction. But unfortunately, all these 3 acknowledgements are lost because the sender doesn't know whether these 3 frames have been delivered properly or not. So what will happen? The sender, because as I told you, go back n, what is the first frame which hasn't been acknowledged? 0. How many outstanding frames are there? 3. So it has to retransmit 0, 1 and 2 again. Okay. So the first packet 0 is sent. But because this receiver is expecting frame number 3 and it sees this particular packet 0, it will assume that, okay, fine, this is a duplicate which I already sent, and it will send an ACK3 next for all the remaining packets. It will discard that and it will clearly identify that the received packet is a duplicate of the earlier one and not a genuine one. This is the case when you have selected a sender's window size of less than 2 power m. Let me show you the other way around. If you assume that if you can take any sender size. In this case, what I did was I have selected the window size is equal to 4. What happens? So my sender can have at any given point of time 4 frames. So it did send packet 0, packet 1, packet 2, packet 3. And once again, let us assume that all these frames have been received correctly at the receiver, but unfortunately, all the acknowledgements are lost. So what will happen? The timer for frame 0 has been expired and the sender will be sending packet 0. But unfortunately, what happens happening here is the receiver is also expecting a frame with sequence number 0. There is no way for the receiver to distinguish the received packet as a duplicate one rather than assuming this as a new one. There is no way for it because it is expecting a sequence, it is expecting a frame with sequence number 0 and it has received something with a sequence number of 0. So it will accept and then forward the duplicate to the upper layers, which is not acceptable. This is a duplicate. But the receiver does not know that this is a duplicate simply because of the fact that the sender's window is equal to the 2 power m. So you have to remember that in case of go back n protocol, the sender's window size is something greater than 1. It is something greater than 1. At the same time, the receiver's window size is always equal to 1. This is your go back n sliding window protocol or go back n ARQ protocol. The second most important thing that you have to learn here is any out of order frames received by the receiver are discarded. It won't accept them. The receiver only accepts the frames that are coming in order. The third important point, the size of the sender's window must always be less than 2 power n. So this is regarding your go back n protocol, and this could be slightly better or more. It could be more made more efficient by adding buffers at the receiver. That is covered under your selective repeat ARQ protocol, which I will cover in the next video. So till then, take care. And once again, if you have any queries, please feel free to put it in the comment section. Bye.